Hello everyone, today we will see how to design Yagi Uda antenna using 4NEC2 simulator. First of all, let's go through this rough sketch of this Yagi Uda antenna. Here in this case, I have drawn the rough sketch for this Yagi Uda antenna. Suppose we want to design Yagi Uda antenna at frequency 300 MHz. So whatever rough sketch I have drawn, it is for 7 element Yagi Uda antenna, where every element is considered as a dipole antenna. So longest element which is there, that is called as your reflector antenna. This D is nothing but driven element, which is nothing but your half wave dipole antenna, and the longest element to this half wave dipole antenna is called as your reflector. All those dipole antennas which are smaller in length than the driven element, these are called as your directors. So total 5 directors are there, one reflector and one driven element. To this driven element, we are giving voltage source. Now how to calculate the length of this dipole antenna? So since we are designing the antenna at 300 MHz frequency, we are getting the lambda value almost 1 meter, and that's why half wave is nothing but 0.5 meter. So length of driven element almost we are taking a 0.5 meter. So since we are orienting all these antennas in YZ in the YZ plane and along the Z axis, so accordingly we have to give the coordinates in the geometry section when we are doing actually in 4NEC2. Let the spacing between these elements is nothing but 0.12 lambda. Actually, you can take the spacing between 0.10 lambda to 0.14 lambda. Now, the reflector length is always 5% more than the driven element. So, we calculated here reflector length, that is lambda by 2 plus 5% of driven element. So, it comes around 0.525 meter. Similarly, whatever is your first director element is there, D1, its length is 5% shorter than the driven element. So that's why we calculated the length of driven element, which is lambda by 2 minus 5% of length of driven element. So it is 0.475, and length of D2 element, it is less than 5% than of D1 element. So accordingly go on calculating this lengths. So here we calculated the lengths of all the elements, 7 elements, as well as we have seen the spacing between these 2 elements. Now we will see how we can implement this data and geometry of this antenna in 4NEC2. So when you open 4NEC2, you are getting this main window. So very first of all, since we will go in the settings first of all after opening this main window. So click on settings. Then click on NEC editor new. And then after this, edit a NEC input file, click on this. So you will get here geometry, which is already I have written all these dimensions for this 7 element Yagi Uda antenna. How to do the entries for this? All elements are your wire antenna. So first wire, which is nothing but your driven element wire, I have given the tag number 1 to this driven element. I have divided that into 9 segments. Now the total length of this driven element is 0.5 meter. And it is oriented in Z direction. So I have given the coordinates x1, y1, 0, z1 is minus 0.25, and x2, y2 again 0, and z2 is 0.25. So that from minus 0.25 to plus 0.25, total length of this driven element is 0.5 meter, whereas radius of the wire is 0.0001 meter. All these dimensions are in meter. Then wire 2 is nothing but it is the description of the length of your reflector antenna, which is spaced at distance 0.12 lambda. So I have taken, since it is to the left, so I have taken this coordinate minus 0.12 and lambda, and the length is again 0.525 meter. Already we have seen in the calculation. So that I have written over here. Radius of all the wire is same. Then wire number 3, it is geometric distribution or description of this driven element 3. So it is also divided into 9 segments, but now it is to the right of your driven element at distance 0.1 lambda. So I have taken it 0.12 lambda. Then again coordinates are minus 0.2375 to 0.2375. So it comes around 0.47 total. Okay. So in this way you have to give all the geometries and dimensions as per we calculated in earlier sheet. Then source load connection. We have to connect this source, voltage source, only to the driven element. So we are connecting it to the tag number 1, and at the middle of that dipole antenna or driven element we are connecting. Since we divided driven element into 9 segments, so middle segment is segment number 5. So we are connecting to this segment number 5 this voltage source. Give all these parameters over here. Then come to this frequency and ground. We want to design this antenna at 300 megahertz, okay, and keep the antenna in free space. So after giving all these details, save all these details and run for this program. First of all, we want to see the far field pattern of this antenna. So click on far field pattern and click on generate the pattern. So if you look at, you will get this pattern over here. So this is what the pattern generated, far field pattern, which is in a vertical plane. Then you can see it in a horizontal plane also. So this is a horizontal plane, and if you want to see both, click on this show both horizontal as well as vertical pattern. Same thing we can observe in 3D also. So come back to the main window where menu 3D viewer is there. Click on this. So what you will find over there? First of all, we want to see the structure, whatever we created over there. So we got the structure. So if you look at total 7 elements are there, you can see the current distribution. First of all, we'll see each antenna is divided into 9 segments. Then we can see the current distribution over there. Okay. So in each antenna current distribution is there because of this mutual inductance, because of the mutual inductance which is created over there. Then we can see the pattern for this antenna, 3D pattern. So this is what the 3D pattern for this 7 element antenna. You can see the transparent view also, then multicolor for this. Okay, so in this way you can study the radiation pattern for this Yagi Uda antenna. One more thing, this is what radiation pattern we have seen, far field pattern. Then if you want to do the frequency sweep where you can study the standing wave ratio as VSWR parameters for this particular antenna, then just click on this frequency sweep and generate the results. So here we got this frequency versus SWR graph for this Yagi Uda antenna. Similarly, frequency versus reflection coefficient. These parameters are very essential to design the antenna. So in this way you can then view the gain as well as FB ratio, front to back ratio, as well as gain for this antenna, as well as what is the impedance for this parameter, R and Z values also you can study. So detailed study of this antenna you can do with the help of this 4NEC2 simulator. And here in this main window you will get the summary of all these parameters whatever are given over there. So in this way you can study your antenna by using 4 NEC2 software simulator. Thank you.